Docker volumes are a powerful way to share data between containers. Docker provides another way to share volumes between running containers, and that is with data volume containers. Data volume containers are Docker containers that don't run an application and just house a volume that can be shared. We can create a data volume container using the docker create command. Docker create is very similar to docker run, except that the created container is never started. Since this container only exists to hold data, we don't need to actually run a process. The parameters for docker create are almost identical to docker run. We will once again use the -v option to specify the volume to mount, but we don't need to specify a path on our host machine. That's because the shared data will reside within our data volume container. We can simply reference the directory we'd like to share between our containers. For this example, we will once again use CouchDB, which stores its data in user local varlib couchdb. We'll name our data container dbdata, and we'll use the Debian Jessie image as our base image. Since our container doesn't need to actually run a process, we can just pass the Linux true executable as our command for the container. We have now created a data volume container. If we run docker ps, we won't actually see anything. But if we run docker ps-a, we will see our container at rest. Now we can start up a couple CouchDB containers to utilize our shared data volume. Keep in mind that running 2 instances of CouchDB or any database on a shared directory is not a good idea for any sort of production scenario, especially if both are writing to the data volume. The purpose of this is to simply illustrate the ability to share data. Let's start up our first CouchDB container and name it db1. To reference the data container's volume, we can use the volumes from option and pass dbdata as the value. This means that any volumes declared on db1 will use our data volume container. And now we can start up our second CouchDB container and name it db2. Since we've already mapped port 5984, we'll use 5985 for db2. Now that both database containers are running, we can try to insert data into one CouchDB and retrieve it from the other. First, let's create a database. We'll call it db once again. Let's post a document to db1 using curl. Now, we can copy the generated document ID and use it to retrieve our Hello O'Reilly document from db2. Remember, db2 is running on port 5985 instead of port 5984. Once again, we see that our second container can read from the shared volume that the first container wrote to. Sharing data between containers on a single host is very easy. Once we move into multi-host container environments where containers and host machines can come and go, data management becomes significantly harder. There are products out there right now that strive to make this easier, such as Flocker by ClusterHQ.